Okay, this is a video that's going to describe some complicated alkane nomenclature, and so hopefully by looking at this you'll be able to use the rules that we talk about to name almost any branched alkane, whether it's complicated or not. Okay, so let's draw an alkane down here and just make it annoying. Put another substituent up here. Okay, there's a highly branched alkane. Now remember, the first thing to do when naming an alkane, or really naming any organic compound, is try to find out which is the longest continuous carbon chain. And so let's look. We can say 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, or 7, 8. Okay, 8's the winner right now. Or 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9's the winner. So this compound is going to be some sort of nonane. It's not cyclic, so we'll just keep it as nonane. Now, what I'm going to do to make this simple is try to just color in green my parent nonane chain here, so I can figure out how many carbons are outside of that chain and what the substituents are. Okay, so one of these is easy, right? We've got a methyl group right here, so I'm just going to write a little note here. One of our substituents is methyl. Then we have this other substituent here. Oof, that thing's complicated, and actually that's what we call it, a complicated substituent. The reason why it's complicated is because it is attached to the parent chain, not at the end of the molecule. So although we have 1, 2, 3, 4 carbons here, this isn't just a plain butyl substituent. This is some sort of special butyl substituent or a complicated substituent. Now, the common name for this is actually a sec-butyl. So we could write that down as the way to name it. We think of this as a sec-butyl because the attachment to the parent chain is occurring at one of its secondary carbons. But what if we didn't know this common name? What if we hadn't memorized that? There's got to be some system in place to name any sort of weirdo substituent, whether we have memorized the common name for it or not. So let's name this as sec-butyl, but let's also figure out another way to name it. Now, to name complicated substituents like this, you kind of treat it as almost a new problem. We're going to name these 4 carbons as its own type of molecule, with a caveat that we have to label this carbon that's directly attached to the parent chain as the number 1 carbon. We don't have any choice in that. The number 1 carbon is the one directly bound to the parent chain. So if I think of this as its own separate problem here, I can ask the question, what's the longest continuous carbon chain with this carbon being number 1? Well, it's either 1, 2, ethyl, or 1, 2, 3, propyl. So propyl wins. We can make these 3 carbons as our 3 carbon parent chain, and then we can designate this 1 carbon as a methyl as attached to the propyl parent. So we can call this a methyl propyl group. And I have to tell you where this methyl is. One way to find out, or to reassure yourself you have to number this methyl, is to say, well, could this methyl be somewhere else? Well, it could be poking out here, and that would be a totally different type of group. So yeah, we're going to call this a 1-methyl propyl group. Put that whole thing in parentheses as a complicated substituent. So really, we can look here. A sec-butyl group is really the same thing as a 1-methyl propyl group. Okay, I've got my parent chain. It's a nonane. I know my substituents. Let's just call them methyl, and then 1-methyl propyl is the one we'll choose to write our full name. Sec-butyl would work too. Now we have to figure out where these substituents are on the parent chain. Here's my green nonane. I have a choice here. I can either start numbering for 1 here, 1, 2, 3, or I could start 1 at the bottom here, 1, 2, 3, and go backwards. Let's figure out which is the best. If I start with 1 at this carbon, 1, 2, 3, 4, 5, my 1-methylpropyl group ends up at the 5th position. I start down here, I could go 1, 2, 3, 4. My methyl group would be at the 4th position. Now, since the first substituent, you want that to be the lowest number, having a methyl at the 4th position is better than having a 1-methylpropyl at the 5th position. So this methyl, well, here's how we're going to number the nonane. 1, 2, 3, 4, 5, 6, 7, 8, 9. This methyl will be at the 4th position. This 1-methylpropyl will be at the 5th position. Now, which one comes first in my name? You'd think it would be the numbering, but it's not. It's alphabetical order. And that alphabetical order would also determine the priority, as if I had to decide which one would be in the 4th position if it was a tie. So methyl comes before methylpropyl in the alphabet. So this is a 4-methyl, 5, 1-methyl. I'm running out of room. Which is common, propyl, nonane. I could also have called this a 5-sec. I'm underlining that because it would be in italics. Butyl, 4-methyl. Nonane. That would work also. Either of these answers is acceptable. What you'll notice is that the substituent locations have sort of switched. Really, the butyl is before methyl in the alphabet. We don't count the prefix sec as part of our alphabet here. And so while methylpropyl is after methyl in the alphabet, and butyl is before methyl, and so the sort of locations of those would switch as I name this complicated alkane.